Good morning, everyone. Welcome to this session. My name is Srini Penchkala, and in this presentation, I will be talking about how to store the messages if you are using the messaging applications, how to store them in NoSQL data stores, and what are the advantages of doing that, and what are some design considerations and architecture solutions for doing that. Both messaging and NoSQL databases offer great support for aspects like performance, scalability, extensibility, which are requirements in most of the applications. So it makes a lot of sense to use those two architecture models together in applications to get the best of both worlds. In this session, we're going to see some demos on how to do that. Also, in typical applications, the messages are unstructured data. They don't follow like a relational data type model. So it makes a lot of sense to use NoSQL data stores, which are meant for storing unstructured data, instead of storing the messages in other stores like file systems or relational databases. It makes a lot of sense to use NoSQL. So let's get started. So I just wanted to kind of go over this goals of this presentation. So if this is something that you are expecting differently, I wanted to kind of make sure that the scope and the format are kind of made aware of in the first 5 minutes of this presentation. So it's not a NoSQL or a messaging introduction presentation. So I'm not going to be talking about what messaging is. I'm not going to be talking about what NoSQL database are. Hopefully, you guys already have some basic knowledge on those two areas. We don't have time to kind of go over the basics of those two. The main target audience for this talk are the integration architects and integration developers. Can I do a quick show of hands? How many are the integration architects or developers or some kind of a messaging? Okay, so most of you guys. Again, the main focus is how to use NoSQL data stores to store messages, and we'll be focusing on my favorite patterns called enterprise integration patterns. And also the focus of this talk will be mainly on a couple of these databases, MongoDB, Redis, and also the new Oracle NoSQL Database. I have some demos I'll show you later in the talk. They're all Java application-based demos, but the concepts are valid for any other language, any other architecture model, whether it's Java, .NET, or any other JVM language you're using. Same concepts, but my background is in Java, so I have the demos in using Java code. Format-wise, this is again planned approach. We got 45 to 50 minutes presentation and demos, and probably last 10-15 minutes for Q&A. But if you have any comment or question in the middle of the discussion, definitely raise your hand and ask the question. Like, I don't know how many of you were in Venkat's session yesterday. So like Venkat said, the best time to ask the question is when you have it, because you know the context, and we can talk about those questions. So if you have any questions or any thoughts you want to share, raise your hand, and at the same time, we can talk about that. Or we'll leave 10 minutes at the end for any additional questions or discussions. A little bit about myself. I currently work as a software architect for a financial organization in Austin, Texas. Recently, I co-authored a book called Spring Brew in Action from Manning Publications. If you guys are working in a Java environment, and if you haven't checked out Spring Brew, take a look at Spring Brew. It's a pretty interesting framework. Even if you don't find it useful in your environment, in your applications, it's definitely a good tool to look at and see how it does code generation and also model-driven development. I also work as an editor at InfoQ.com. How many of you heard of InfoQ website? It's definitely a good website to check out. They got a lot of free content on interviews, articles, and also if any of you are interested in writing articles for InfoQ, let me know after the talk. A quick background on this. Again, my background has been mainly in the financial services side. So performance, scalability, security are always top requirements. We have to deal with a lot of regulatory compliance standards like PCI, FISMA, or SOX. Mainly G2E architecture model is what I'm used to working on. And also we use Scrum, Agile for software development process. And also, as you can see, the last sub-bullet, there's always this conflict and challenges between being agile and also doing the architecture the right way. So there's always interesting stuff going on between those two aspects. I just wanted to do a quick poll, before we start the discussion. How many are using messaging in their applications? Pretty much most of us, right? So, and then how many are familiar with or using EIP, Enterprise Integration Patterns? A couple of them. So that's definitely a good book to check out. Even if you don't like patterns, if you want to read a good book on patterns, this would be the book. So definitely my top 5, one of my top 5 books. How about NoSQL? Has anyone used NoSQL or using it in production as well? Okay. And then any application frameworks for ESB, EIP, like Spring Integration, Mule, Service Mix? There are a few of them. Okay. And then how about Spring Data? That's still in just came out in 1.0 release, but definitely helps how to abstract the data access logic for the NoSQL databases. So definitely, I think you guys are the right audience for this discussion. So, in today's discussion, we're going to cover these topics. We'll look at messaging patterns and those specific patterns that require those messages to be stored for further processing. There are a lot of patterns you don't need to worry about messages need to be stored, but we're going to look at those patterns that where we need to store the messages and retrieve them. So we're going to look at those patterns in more detail. Obviously, we look at NoSQL databases as the message stores. So instead of file system or relational database or some other way, we're going to see how we can use NoSQL databases for persisting the messages. Also, like I said, the concepts are valid for any environment that you are working on. But for this context, I'm going to be using Spring Integration framework and the Spring Data framework, because these two frameworks make it a lot easier to develop demo applications, for example, or even the real applications to connect to either messaging systems or NoSQL databases. So I'm using these two frameworks to make my job easier to connect to those two models. And also we're going to look at what's called a message store strategy. This is one of the patterns we're going to talk about. How a message store works and what are the design considerations for using message stores. We're going to look at a sample Java application, and also, this is all cool, but we do definitely want to talk about what are the downside, what is the downside of this, or what are the limitations of this approach. So you always want to know what are you using and what are the limitations of those patterns. And then we'll have some conclusions at the end. So messaging, right? So we have all worked on messaging or heard about it. There are a lot of advantages. Like anyone wants to say a couple of advantages? Why do we need messaging in some use cases? Any advantages you guys can tell? Like loose coupling is one of them, right? And then performance, because there are more pieces working independently, so you can definitely get a better performance. And also scalability, extensibility. So all those are advantages. Also, there are some limitations, right? Since there are all these components in the system that are loosely coupled, there is a probability for messages that are being transferred between these components being lost, and then the whole system, basically will become useless if the messages are lost. The data integrity problems will arise. And also performance, sometimes if one component goes down, the whole system can go down. So that's also, or if one component is slow, so that is the weakest link in the chain, so the whole system can be slow as well. So security is also important, because you are passing messages back and forth between these different pieces, different components in the system. So if security is of concern, how do we not pass the message, which has some sensitive information to other components that are not supposed to get access to those component security information. And availability, again, like I said, if one component goes down, the whole system is down, right? So availability. Any other limitations you guys can think of, messaging wise? Definitely, it has a lot of advantages, but also you have to be careful about how you design the systems. And then we're going to look at the design considerations. That's the main focus of these presentations. So there are advantages. We want to get that take advantage of those the power of messaging systems. But also there are limitations, so what can we do to address those limitations? Like I said, these are some of the messaging patterns that we're going to talk about more in this discussion. Like I said, that's the book, that's the cover page of the book. Definitely, I met Gregor, one of the authors, back in 2004 in a conference in server-side conference, server-side symposium in Las Vegas. So definitely, that's when I bought the book, and I've been referring it almost every day for the last 7-8 years. So definitely a good book, a lot of patterns, and almost all patterns are very useful if you are working in asynchronous messaging environment. And also there is a good website, the URL is at the bottom of the slide. If you don't want to buy the book, go to the website. There is a catalog of patterns. They describe the pattern names and how those patterns should work. And again, like Venkat, I don't know if you guys been to Venkat's talk yesterday. Like Venkat said yesterday, don't use the patterns to create the solutions. Let the patterns emerge from the solutions. So a lot of the times, when you go to job interviews, they say like, what patterns have you used? People will start saying like MVC, strategy, singleton, all those patterns. And I don't like that approach. I would like to see us create solutions and let the patterns emerge out of those solutions rather than patterns drive the solution. So let's go through this layer. Message store is the main pattern we're going to look at today. And the claim check pattern is another one that takes advantage of message store. Queue channel is one of the patterns that's like probably the main backbone of messaging application. Aggregator is a messaging component where you have a message that kind of split into different pieces. Aggregator actually adds up all those message pieces to make a single message at the end of the process. And resequencer is when you need a bunch of messages to be sequenced differently based on the use case. And the last two patterns, control bus and wiretap, are mainly for the monitoring purposes. So since there are a lot of pieces in the architecture, the messaging architecture, you want to make sure that you have a good way to monitor and manage what's happening with each of those components. So Spring integration actually provides implementation for these two patterns, control bus and wiretap. They are again not the core patterns, but they are mainly for the admin purposes. So the first one is the message store. Like I said earlier, this is used to mainly store messages in a persistent data store, and we'll look at how we can use NoSQL for this particular use case. As you can see in the diagram here, the message, there is a message icon, so it comes through, and then we actually store the message here, and then when we are ready, we just pick it up from the message store and continue the processing. So why do we need a message store? Like I said earlier, we need it for performance. Sometimes you don't want a message that is that has a lot of information, like a large size message. You don't want that big message to be passing around between the different components. If let's say you only need 5 fields out of a 50 field message, do you want to carry that 50 sets of data throughout the use case? It would be nice if we can basically filter those 5 pieces into a separate object and then use that for the most of the use case, and then go back and get the full message when we are done with the use case, right? So we don't want to carry around large messages. That's where the performance and network bandwidth going to come into picture. Availability is you want to store the message so it's not lost anywhere, and you can go get it when you need it. So here are some of the use cases for using message store. Like I said, there are some of these components in some of these patterns, if you want to call them, like aggregator, resequencer, and queue channel. The way they work is basically they buffer the messages. For example, aggregator, right? So aggregator's main job is to collect several messages and then aggregate them at the end of the use case. So to do that, it will actually, whenever it gets a message, it's going to store the message, buffer the message somewhere, because it needs to get all the messages first, to add them up. So what happens is when it's buffering the message, if any of those messages are lost, the whole integrity of the use case is pretty much lost. So because we only have few messages, some messages are lost. So how do we know what we have is the right collection of messages? And same thing with the resequencer. How can we trust the resequencer if some of the messages are lost in the way? So any of these components that do the message buffering can take the advantage of this message store pattern and use NoSQL to store those messages. Also, I talked about claim check pattern, which is we'll look at more in detail in next couple of slides. It's mainly for message loss prevention. How can we use the claim check pattern? For example, this morning I left my hotel. I couldn't get a hotel in this area, so I had to get a hotel like in a half an hour ride from here. So I got my luggage to a hotel this morning, and I gave it to the bell service folks, and they gave me a what they call claim check ID, the tag. And this is exactly how this claim check works. Claim check pattern works the same way. You basically ask the claim check pattern, to store a message. It will basically give you an ID, like a tag, and then you do your business processing and everything. And when you're ready to go back and get the message, you basically call the claim check and say, okay, I'm ready to check out my message. Here is the ID, and you get the message back. So that's how it works. Again, the performance, we talked about that message size concerns. Security is the same way. Sometimes you don't want to send the whole message throughout the use case. You want to filter it out and only use the fields that are allowed to be viewed by the different components. Claim check message, like I said, it stores the message data in a persistent store and basically gives a claim check ID to subsequent components. And when we are ready, we can just go back and get the actual message back. So you can see the diagram right here. Check luggage is the use case. We check the message here and get an ID, and when we are ready, we just get it back, and then go through the rest of the steps in the use case. So, like I said, all these components that need message persistence, there are a few different options to persist those messages. There is a in-memory option, so you basically store the messages in the memory. This is probably the fastest solution, but again, it's not reliable. So persistence and memory, they don't even go together. I guess those two words. So this is mainly for testing. If you are testing something, you can use the in-memory, for the faster testing. But we don't want to use this approach in production environment. So next option is the relational database. We can still use the JDBC API, to persist these messages to relational database. It would be like persisting a non-relational data into a relational database, which we have done in the past, before NoSQL databases came along. So that option is already there. And then the third one, which is the main focus of this talk, are the NoSQL databases. There are a few different options. Again, in NoSQL databases, there is a key value data store approach, which is where the Oracle NoSQL, the React, and the Redis, those databases are under this category. So this is the best candidate for storing messages. Usually messages are like a key value, right? You need a message key, so you can go back and get the message from the data store, and the message itself is more like an object, value object. So key value data stores are the best candidates for storing messages. But also we're going to look at the document database, the MongoDB, how you can do this in MongoDB as well. And Spring Integration has support for Gemfire as well. Is anybody using in the room Gemfire? It's basically a data grid. This is kind of gets into that whole NoSQL new category that's coming up. We had relational databases for a while, and we had NoSQL for the last couple of years, and now this new trend called NewSQL is coming out. And Gemfire and the SQLfire, they kind of fall into that. So kind of more in-memory, taking advantage of in-memory data grids, and still getting the persistence advantage. So any questions on the patterns? Do you guys have any thoughts on the patterns, why we need to store the messages for the security and the performance and the message loss prevention use cases? So next topic we're going to talk about is how do we get the NoSQL databases into the implementation of this model. So like I said, these are the NoSQL databases that are currently supported by Spring Integration. We have Redis, which is a key value database. It also supports out of the box publish and subscribe messaging adapters. So if you are using messaging in your applications, Redis is definitely a good one to look into, because out of the box it supports publish subscribe messaging pattern. So all you have to do is basically configure the adapter, and you can implement the pub sub pattern in your applications. The second one is yeah.
So you didn't get to in your choices, like what was your SLA for latency and throughput requirement, and why would you choose one versus the other?
Between right, yeah, it all depends on the requirements. Usually key value, which is Redis and Oracle NoSQL or React, those are better options. Like if you, let's take another use case, like for example, session management, right? If you have users logging into your website and you want to scale well, when there are a lot of users logging in and you want to keep track of their session data. So session object is mainly a key value type of data type. You have a session ID, and then you have the session information, right? So that's a good example of using a key value data store. So the same thing with messaging here. So it's a key value data store is a good example. And a lot of these are also very specific to your environment. So there is in theory.
Some of these numbers, like what was the latency if you want it, what was the that you had?
Yeah, actually we didn't test all these in production, so we tried them in test, and then used one in production. So I can probably talk to you more. What's the background of this project after the talk. So, and again, those numbers are all just the numbers. It's like presidential debate from last night. You hear a lot of numbers, and they all need to be taken into a context, right? So. And definitely between relational and NoSQL definitely has advantage. But again, it all depends on what you're trying to do. If you are trying to store relational data into NoSQL data stores, that's not going to be a good use case. We want to. I mean, that's one thing we need to. Probably you already thought about this. NoSQL databases are not going to replace relational databases. NoSQL databases are going to augment or complement relational database, right? So we will always have relational data. That's probably 70-80% of our data sets are still relational. So you want to use relational database for that. And for any other data types, and I think we had this challenge about like 6-7 years ago when Hibernate came along, the ORM frameworks came out. So in my opinion, ORM is like a good solution for a right solution for the wrong problem, right? We were trying to take the object model, so the data in the Java objects, and store them into databases which were mainly relational at the time. So what happened was, instead of creating databases that are more object-based, what the community did was they created this bridge in between, the layer in between. Okay, you give me objects, I'll translate them into relational, and then I store. So along came, flexibility was there, and it was kind of more that developers don't have to worry about the relational databases, all that good stuff, right? The mapping is all almost automated. But again, the performance was hit. So if we still have a lot of use cases in my company where ORM doesn't even scale. Actually, we don't even use EJBs because EJBs don't scale. So there are some use cases where you cannot just depend on ORM. So I wish they had come up with like NoSQL at the time, or NoSQL should have gotten more attention 6-7 years ago. So anyway, good news is like now NoSQL is getting more attention. So that's definitely good solution. So yeah, going back to the discussion, that's what it is. Like you have relational, you have NoSQL, and now they are coming up with this in-memory data grids. So these are all basically patterns. They are solutions for different problems. So if you use them for the right problem, you will definitely see good results. If you don't, you're going to run into challenges again. So again, like I said, Oracle NoSQL is a key value database as well, and it supports ACID transactions. As well as good administration support is there. It's kind of one of the new databases, so you want to definitely try it out first before actually jumping on it. And then MongoDB is probably more stable in the NoSQL area. It's been around for a while, and it's used for storing document databases. Anyone using MongoDB today in production? Okay, cool. So what kind of a use case, what kind of data do you store in there?
Emergency response system.
Okay. Okay.
The spatial aspect of MongoDB.
Spatial, okay, that's cool, yeah. Okay, cool.
The spatial index.
Yes, that's right. Okay, good. Any questions on NoSQL database? Any other thoughts? Are you guys using any other NoSQL database? I know there are like a lot of them.
I use HBase.
HBase, yes, that's definitely it's a column family, right?
Yeah.
From Apache, yes, that's definitely one of the probably most popular database, I guess, right? It's been a while. It's been around, and Cassandra is also another good one, right? So let's get into the application framework side. And most of us are developers. I'm guessing, so definitely we want to kind of learn more about how can we. Okay, NoSQL database are great, but I'm not a DBA. I'm not a dev. I'm not an operations guy. So what does it mean to me as a Java developer or a Java architect? So this is where we kind of get into the application frameworks. And again, for this discussion, I'm using Spring Integration and Spring Data. You can probably use any other API or write your own frameworks. You don't want to, but if you need to, you can write your own data access layer, for accessing these databases. So Spring integration, right? Did I already ask you how many are using Spring integration? There you go. Okay, it's definitely a good framework. Like if you look at that book, the enterprise integration patterns, and if you really like it, and if you think about, is there an implementation framework in Java that does everything that this book talks about? That would be Spring integration. Basically, Spring integration is a implementation framework of all those patterns. So if you need a message store, or if you need a queue channel, if you need a routing slip pattern, I used that like two companies ago. So they're all pretty good ones. So
Have you looked at Apache Camel?
Apache Camel, yes. Actually, we are using that in one of the small projects right now. Yes.
And
And
why did you end up deciding on Spring integration versus Camel?
yeah, most of our applications are already Spring based. So it kind of makes a lot of sense. We have the skill set, we have the familiarity, and it's just a good extension to that, right? So, and then also Mule ESB is another product out there. So that's another good one too. So also with the whole cloud computing paradigm, they are coming up with this integration as a service. It's like a new X as a service pattern. So you're going to see a lot of these ESBs behind the scenes running on the cloud, doing a lot of the things. So definitely a good space to kind of keep an eye. So Spring integration basically is an extension of Spring framework, implements EIP patterns. It's very lightweight, easy to unit test, and also it provides integration with a lot of the external systems. Like if you have a batch process that you need FTP, email, RSS, and all those kind of typical requirements, Spring integration and will definitely have these adapters to do all that. So you just write simple configuration and it's good to go. So, and also it supports the separation of concerns. So you have the application logic not getting polluted, I guess, from the infrastructure logic. So we want to keep the messaging logic out of the business logic. So Spring integration does that. You write all your business logic in Java classes like POJOs, and you use the Spring integration configuration to basically use those components to make it a messaging system. And the other framework that I use this in my demo is called Spring Data. Already talked about this. It provides data access logic for the non-relational databases, as well as the MapReduce frameworks. That's where the whole Hadoop and those come into picture. And then currently it supports pretty much all the NoSQL databases. If you go through the list, we have Apache Hadoop, Gemfile, key value stores, document database stores, graph databases, and column stores, HBase. And then more of them are coming. So if you are using any of these databases in the backend and you are getting into a situation where you're writing a lot of code to access these databases, Spring Data might be something to look into, see if it can make your job easier. And the third framework I want to just cover at a high level is the Spring Roo framework. Like I said, it's a rapid Java application development framework. So you run few commands and it will create a simple web application, all layers. What I call is like a URL to SQL. It creates all the classes. So if you have like really simple requirements, you can just run the Spring Roo and then you will have a working application in less than an hour. So. And then we have done this in my projects as well. We create the foundation code base, using the Spring Roo, and then Spring Roo is like non-invasive, so it doesn't lock you into the model. So you run the Spring Roo commands, you create the base foundation like log4j properties file, Maven build file, DAO service, all layers of the application classes, as well as the view layer, JSP, all that good stuff, transaction configuration, security, all that stuff is out of the box. So once you do that, like within half an hour, within 1 hour, you have a working application, and then you can remove the Spring Roo from the picture, and you can work on that application. You can add your own logic, So definitely helps with creating that foundation of the application. And the cool thing also for this discussion, it provides nice integration with Spring integration as well as Spring Data frameworks. So if you like Spring integration and if you like Spring Data, and if you don't want to manually write a lot of code, you can use Spring Roo to auto-generate a lot of that code. So basically, we're just talking about different levels of automation. Anyone has heard of Spring Roo or using Spring Roo right now? Okay. So with that discussion on frameworks, let's get into the message store, which is the core focus of this discussion, like message store based strategy. Basically, it's based on the strategy design pattern, the gang of 4 patterns. So there is a message store strategy which is used by queue channel and claim check patterns, and also there is a message group strategy which is used by aggregator and resequencer. So depending on which patterns you are using, you would be using this particular implementation. And these are all basically interfaces, so you can always implement your own custom implementation if you want to do. That's what I did for the Oracle NoSQL. Oracle NoSQL didn't have a implementation out of the box, so I just wrote my own custom implementation. So these are the implementations that are available right now from Spring Integration Framework. So there is a in-memory map-based message store, which you want to use for just testing. And there is a JDBC store, and there's a bunch of NoSQL data stores. So these are the 3 categories. Okay, and again the same list in a more visual format. So we have the message store interface on top. There are 3 categories of implementation: in memory, JDBC, and NoSQL. And within NoSQL there are 4 of them: Redis, MongoDB, Oracle NoSQL, and Gem5. And this is how you typically configure a message store. For example, let's say we have a queue channel. So you have a like a JMS, basically you have a publish subscribe queue, point to point queue channel, right? You want to send some messages to that queue, and you want to retrieve them from a receiver. So this particular component, if you don't specify the message store here, those messages are basically not persisted, and there is a possibility you would lose them. But if you want to take the advantage of the message store, you would just use the message store attribute, and you basically define, specify what message store you want to use, in memory or Redis or Oracle NoSQL, MongoDB, or one of those. So this is how we configure, and as you can see, it's pretty straightforward. We just add this message store attribute to the queue channel, and you are good to go. Same thing with the aggregator. And if you have an aggregator that's expecting messages from an input channel, and when it's done, it's sending the aggregated messages to output channel. And you want to, in the meantime, you want to persist all the messages it is getting before it aggregates. You can just use the message store attribute. So these are all optional. Message store is optional attribute, so you can not use it, or if you want to persist, you can use it. So, any questions on that? Pretty straightforward. How do you configure? This is basically, if you guys are familiar with Spring, this is how Spring works, right? How do we basically inject all these components? How do we associate these components? How do we add these capabilities using the XML configuration? So let's look at some demos. We got half an hour, so that's good. Any questions before we go to demos? Any thoughts, questions?
If you may elaborate a little bit about the resequencer pattern.
Resequencer?
The aggregator make chunks of messages.
Yeah, basically, let's say you get a bunch of messages. Let's say you get 50 messages, right? And then you want to take the advantage of parallel processing. You want to split them into 50 individual messages, and you want to process them at the same time using multi-threads, whatever, right? And then when they are done, the requirement is you want them in the same sequence. You want message 1 to be in the first spot, and then 50 to be 50th. So this resequencer, you can use that, say, okay, I want put them now, they're all done, put them back into the sequence.
So after they are being parallelized, you group them again.
Yes. So basically group them and sort them, exactly, if that is the case, right? So, and then again, if you go to the website, the patterns website, they have a good description on each of those patterns. Right. So there is a splitter pattern where you split the messages, and then you process them, and then if you just want to aggregate them, you can use aggregator. But if you want them in a particular order, you resequence, so right. Definitely, I think the patterns, again, I like that book and like the website, because it's not specific to any technology, the author doesn't try to sell you anything. It's a really good patterns book. So patterns are basically best practices, right? So they make sense if they are used in the right context. So sample application that actually I am going to post it on GitHub after this presentation. So, but if you guys need a copy, just shoot me an email or give me your business card. I can send you before that. It's going to be using all these technologies: MongoDB, Redis, Oracle NoSQL Database, Spring integration, of course, to make the job easier for the messaging side, and Spring Data to make it easy to connect to the NoSQL stores, right? And JUnit, of course, we want to be able to test all this from a from a unit test standpoint. We don't want to run this on a container, right? Just for testing. So the first use case for this demo application is the claim check pattern, like I talked about earlier. So at a high level, again, I'm not good at using the PowerPoint animation stuff, so I just, hopefully the content is good enough for you guys to kind of get the value out of this. Again, the look and feel is not that great for these diagrams. So message basically comes into the queue channel is the first entry point, and right here you can see queue channel. We are storing that in a message store. So just for the discussion sake, I am using different message stores for different components. Just kind of show you guys, how what is all possible here. So I'm using an in-memory message store here, but in production you don't want to use in-memory store. This is just for testing. And then once the queue channel gets the messages, the messages go to a transformer. So in transformer, you basically can change the message to be more meaningful for the intermediate steps. And then once we do the transformation, and we can do the claim check. Okay, now I have this big message. I don't need all of this, for the further processing. I just want to store it somewhere so I can come back and pick it up later. So we use the claim check for that. And this is the check-in. This is the first step in the claim check. We actually check in the message. So we put that into a message store, and here I'm using MongoDB for the persistence. So basically we get a claim check ID, and we hang on to the claim check ID, and we go through whatever number of steps in between. It can be, in this case, I'm using a header enricher, just kind of do some processing. It can be anything. You may have like in this header enricher, you may have like 10 steps, to do your business processing. And once you are done with all that, you come back and say, okay, now I want to go get my original message. So that's when you do the claim checkout. You call the message store and give the ID back, give ID and get the message back. So that's a pretty high level description of the use case. Yeah.
In that header enricher, do you have the message here after you check in the message in the message store? Is the message still in that pipeline between the claim check in and checkout? Do you still have the message, or just have the reference to the?
Just have the reference. Huh? Just have the reference.
Just the
reference to the message. Right.
So
Exactly.
Around with only the reference.
Right. I mean, you may still kind of filter out the big message into a small message, and you can go with that message. But the real message, you only have the reference to that. So right, exactly. And that's the idea, right? So we want to, and then here header enricher is only just an example. You can do any other processing in between the check-in and check-out, right? So okay, let's look at the demo. I haven't tried this in a while, so hopefully the demo works. So let me start with the configuration side. I showed you guys right here. This is the queue channel. Can you guys see that okay in the back? Yeah, let me see. This is a Windows machine, so I see if I can. I don't remember how I do that. Oh, fonts, okay. Okay, cool. So Java, right? Oh, that's XML actually. So basic is good. Dialog font. Text font, right? Let's see, Korean new, that should be good. 12. Really? Okay. That includes me as well, so. Is it better? Okay. But again, I think I'm going to make this available on the GitHub, so if you guys want to have access, I mean, if you have time, definitely this is very easy to set up and run. It's all a Eclipse project. You just download this and run it, so you don't need any Tomcats. I mean, you do need to run those database outside, but I'll make everything as a part of the package. So this is how we define the queue channel with the message store, and we are using an in-memory message store, and we are using basically a poller, to just keep running this for test. Let me just quickly go down here, and then this is the claim check. I talked about. We are using a gateway component. Again, gateway is another pattern, and basically I just created a class. Or actually, this is mainly an interface, so that actually gets a message from the queue channel and then does the claim check-in. So right here you can see the claim check-in. This is the actual claim check-in configuration, and then we are using a MongoDB message store here. And then we do the header enricher, just some change the message a little bit. And then service activator is like a business class, where you have the Java class doing the business processing. And then we do some transformation again, just kind of add some steps in between. And then there is the checkout. Again, we go to MongoDB message store and get the actual message out. And the remove message is basically an option where you can say, okay, now I got my message, the real message, go ahead and delete the old one, or you can keep it if you want. So. And the control bus is mainly for management, the monitoring of the system. And this is where we define the message stores. You can see how pretty straightforward it is. So we're creating a bean with the message store, and this is a simple message store, which is in-memory message store. And again, you don't want to use this in production, just for testing. And then MongoDB is pretty much the same. Let me see if I can press enter here. You can see that. Okay, see that just so for MongoDB, we need to create the MongoDB data factory, the connection to the database first. And then we just create the message store DB, which is right here. So again, pretty straightforward. We just use the class, that comes out of the box from Spring integration, right? So let's go ahead and run this. I'm actually running MongoDB, on one of these consoles. So let me go ahead and run this test. It's called a claim check message store. So now the test is running. So if I go to MongoDB, you can see like there is a connection. See that the connection, we got a connection from the application, and connection opened and closed. We go back here. It should be okay. Test ran fine on console. Just a couple of messages, so nothing. It just claim checked it. So that's basically what happened. So the message was again this a simple test, so it runs really fast. So what you guys can do if you have time after the conference, just try to run this and see if there is a way to make it lose a message and see what happens. Kind of create those fail scenarios. So that's but from a discussion standpoint, it's pretty straightforward. You can just create those configuration and then use that message store attribute. Any questions on that quick demo? It's pretty straightforward. Go. Actually, I did a presentation last year, a Java one, like BOF session. Actually, I used Glassfish to store messages into a MongoDB database. But I don't know about WebLogic though. I know Glassfish, you can get working with Glassfish. But WebLogic, if it's not there yet, I think it's definitely should be coming. Because it makes a lot of sense to use a NoSQL database for messages, right? So I'm sure it's going to come out there. I haven't heard about it, but I'm sure it's on the roadmap for the Oracle folks. So that's the first demo. Let me quickly go back here and say second demo. This is actually using a different component called aggregator. Again, here we get the message, and again we have a queue channel. We use a message store, but for this example, we are using a Redis message store. Kind of show you guys how it works. And we have a transformer again in the middle. And then we have an aggregator that is going to use the Oracle NoSQL message store. So pretty straightforward here. So let's go back here and look at the code. So again, this is just basically XML configuration. So we're just moving, I don't know what you guys think about XML, but we're just moving a lot of logic from Java code into XML, right? Which may be a good thing or bad thing, I don't know. And now we have annotations, right? So we got moving all the logic from XML into annotations. So again, those are all useful, like they're all patterns. To me, everything is a pattern, right? So XML, annotation, or Java code, they're all useful for a particular context. So use them where they make sense. So let's see, we could start from the queue channel. I think that's on the top. Yeah, right here. So queue channel, again, we are using a message store, which in this case is a Redis message store. And then for aggregator, we are using we're also using Redis store. Okay, we could probably change it to Oracle as well if you want to. So I do have a Redis. This is the Redis message store. Let me press enter here. You can see that. Actually, what I did was I just created a custom. Just put some system outs to see it's working. Actually, you can just use the Redis message store if you want the one that comes out of the box. And for that, we need a connection factory again, just to create a connection to the Redis database. This is the connection factory, and then this is the Oracle, that I created, so. Which in some cases is having problems converting the Oracle key value objects into Spring message objects. There is some translation issues going on, but that's why I think I'm using the Redis for both of them, example-wise. So let me go ahead and run this guy. Actually, I think Redis is running here. So this is Redis database running here, and Oracle is running here. But Oracle NoSQL is basically a Java application. You just run as a Java application. So let's go ahead and quickly run this demo. It's called external. And then this test, actually, I didn't really write a lot of the code for this. I wanted to kind of keep it simple. So I basically used some of the examples that come out of Spring integration installation. So I just took those examples and I created I just added the message store logic to those. So you can see right here, I think it's still running here, external gateway. And if I go to right here, you can see we are doing a polar, so it's sending the messages, multiple times. So you can see one client connected, so this is the Redis database console. You can see that it's accepted a connection from this IP address, that port number. So now the messages are being stored. You can probably see here how many messages, 22 keys. It keeps adding more messages with the. So you can see this keys number going up 20 and now 22. So I can now basically stop the test anytime, and then I can see client close connection right there. So that's pretty straightforward, right? So, and then if I want to use Oracle, I just come back and say, just use the Oracle custom NoSQL. So it's pretty straightforward. Let me actually go to this class and I can see how I can show you guys how easy it is to. Okay, there you go. So this is the Java class I wrote to basically bring the NoSQL, Oracle NoSQL into the message store architecture. So Spring integration has this class called abstract key value message store, and Oracle NoSQL is a key value data store. So we just make sense to extend this abstract class. And all you have to do is, let me scroll down. You can see right here, you initialize the key value store, which is a Oracle NoSQL Java class. And then there is a do retrieve method you have to override. So how do you get the message out of the message store? So you can see I'm just using the Oracle NoSQL API here to get the message back. And the other method you need to, I can probably clean this up a little bit. So.
I have a question. Is there any kind of integration with the Spring transaction management towards these data stores?
Yes, yeah. Especially, definitely for a JDBC implementation. If you are doing this as part of a transaction, and if the transaction is committed, then the message actually is taken out of the message store. If the transaction actually rolls back in the middle of the use case, the message it still stays in the message store, so you won't lose it. So is it, right now it's only, I haven't tried with the NoSQL, but we can probably look at it. It makes a lot of sense, right? So to make a transaction support. So the documentation only talks about JDBC, but I'm sure because yes. Exception handling? Well, how much time do we have? It's again depends on the context, right? You have to see. I mean, Spring integration does provide. Right. Again, it depends on the use case. From my experience, I can speak about a couple of examples. There was one use case, where we were actually calling a external entity, external company, their web service. And then there is no guarantee when that web service is going to be up or down, right? So when we get a timeout or whatever, right, for whatever reason, so we actually retry a few times to make sure that it is up, it is still working, but we are not able to connect. And then if it works, so the use case goes to the next step. But if the service is really down, let's say it's not going to come back for a couple of hours or even a couple of days in some cases. So then we don't want to wait for that long, right? So we put that message into a queue to try later, so you can depending on that's kind of more using the messaging solution to addressing messaging exceptions, right? So there are a few different ways to do that. So we can talk more. If you give an example, I can probably talk from my experience again, which is only 15 years old. So again, I can see like do store is the other method that we need to override. This is again how do you store the message into the message store. So again the conceptually this is all same for any implementation. This is just the Java syntax. And then there is also a do remove. How do you remove the object from the message store? So once you implement those three methods, you are good to go, at least at a high level. So.
Can you show us broker configuration for MongoDB?
MongoDB configuration.
The broker configuration that you.
Oh yeah, actually so I'm using Spring Data right now. So it basically doesn't. You don't need to really configure too much, a lot. So there is a Mongo instance. Let me scroll back real quick here. Okay. So there is a MongoDB factory. You create the Spring Bean, right? And then that's where you specify create an instance of this class, which is this COM MongoDB. Mongo is your actual database from an object side. And you say, okay, create an instance of this, send it to the MongoDB factory. And then actually we also sending the message store here. But anyway, yeah, this is basically your MongoDB handle configuration. So pretty straightforward. So if you use Spring Data, that's advantage. But if you're not using this, you may have to create the broker and programmatically or declaratively, right? So it's pretty straightforward on that. So again, all the frameworks I'm using may not be applicable in your environments, but again, the concepts are still valid, right? So
I have a specific question.
okay, good enough. Yeah, I'm here after the conference session. So again, we talked about this. How do you custom implement? Your interface is there, you implement it, or you can use that abstract class for the key value data stores. You can extend that. And let's quickly look at it. For 8 minutes left. So limitations, right? Again, going back to the question from you, messaging is powerful, but with power comes responsibility, right? So you have to be really responsible for how do you manage these several components, that are loosely coupled, but any one of them can go down at any time. And especially in my case, if you're calling these outside companies, the control is completely out of the window, right? So we don't know when they're going to be down. Sometimes we find out their services are down before they find out. So we are calling them or we are emailing them, hey, your service is down. So having a nice monitoring management system, which some of those patterns actually cover that, like JMX or any one of those. So basically is definitely, yeah, you almost want to, if you're working on a messaging implementation project, you don't want to wait for the monitoring piece until the end of the design. You want to make it as a requirement, core requirement of the solution. So monitoring, administration, how do you test these, and if they're up or down, or what do you give for the operations folks to test these before they call you in the middle of the night, right? So some of the limitations are basically, again, these are very specific to Spring implementation, Spring integration implementation. So message data is basically serialized and deserialized because there's a lot of serialization and deserialization going on behind the scenes between those components. So sometimes, it uses different strategies. So depending on what use case you are using, how it's working, how it's being serialized, you may see some unexpected behavior. So you want to make sure that you address for that in the design. And like I said, JDBC message store, only serializable data is persisted. So you want to make sure that you make the data serializable, so it's persisted by default. And also with the Spring, when you depend on the Spring container for IOC, the dependency injection, when you ask for a new instance, it may not be the same instance. It will give a different instance of the bean, right? So you want to make sure that those kind of situations don't cause any problem in the use case. So, and then they say use the channel names instead of channel instances. The channel name is more easy to resolve. If you have to reference a channel, use the channel name rather than the ref attribute. And other than this, any limitations that we talked about, exceptions wise or in general, they all apply for this messaging system, right? So anything that can go down will go down in messaging system. Let's quickly some conclusions. We looked at messaging persistence. Why it's needed. What patterns are definitely need to persist the messages. We looked at message store pattern. Let me go back here. Actually, sorry. So we looked at the message store pattern and also claim check pattern, which is a good business case for storing the large message and then get it back when you need it. And we also looked at how NoSQL, which is definitely a hot topic right now, and messaging, which is also a interesting topic. How can we take the advantage of both models to persist the messages? And we also looked at some frameworks, which kind of make the job easier. They may be okay to use in your companies or may not be. But again, the concept-wise, those frameworks definitely add some value to the whole solution. And this is I always put this last bullet in all my talks. So all these ideas, proposals, recommendations, all definitely you have to take them with a grain of salt. Whatever worked for me may not work for you, so you got to look at the problem first and then find the right solution, right? So one size fits all fits nothing, right? So some resources real quick. These are probably some of the books. Again, the first one is technology independent, very pattern oriented. You can at least go to the website and see find anything. Again, the second book is the implementation of the first book, I guess. If you are looking for, okay, I like all these patterns, I want to learn more about this without writing everything from scratch, then you can use Spring integration, and that book is a good, it just came out like a couple of weeks ago. And the third book is, I wrote this book, Spring Roo, if you want to, again, go to the next level, okay, I don't even want to configure this XML, by hand. I just want to run a command, like create queue, create aggregator, and then I just want the framework to do everything. That is Spring Roo actually, so pretty straightforward, at least for the testing anyway. So and there are more resources. You can look at this. The slides will be available on the website. A lot of good stuff. Again, my contact information. You can email me or send me if you like this talk. What are the improvements I can make and suggestions. And that's it. So I do have some bonus slides if you guys want to take a look at them later. But I think time-wise, we have 3 minutes left. So I know we had some questions during the talk. That is good. So we probably don't need as much time now. So go ahead. Okay, so I think that should not be much different from how, let's say, if you are using a JMS, like a WebLogic JMS server right now, the same, basically we're just using a different data store, right? So, right. So I mean, yeah, you can probably because the NoSQL out of the box doesn't give you the cap theorem, right? So you can have the consistency, availability, and partition tolerance at the same time. So to address that, you may have to put some logic in the middleware layer somewhere to make sure that those things don't happen, right? So it all depends on you are pushing the complexity from one layer to another layer, basically. That's what. I know this is kind of a new topic right now, so I'm not familiar with any out of the box. I mean, it is an open source. I'm not familiar with the open source side, but there are a lot of commercial implementations. They definitely are well ahead of the rest of the community. So if you, I don't want to say any names, but you can talk more on the commercial implementations. There are a lot of them out there. So they've been around for a long time, and now they are coming out of the woods, I guess, because NoSQL is getting a lot of attention, right? So any other questions or comments? How?
Comment on the benefits of using NoSQL for a message store, like what scenarios you would use NoSQL versus traditional?
Right, yeah, depending on the performance requirements, right, or scalability. Most of my experience has been in a highly scalable, highly transactional applications. So you can go from a few hundred users to a few thousand users, more than that in a pretty fast time. So you want to be able to add the flexibility to the components to grow up or grow down. So that's where and NoSQL also gives you the faster way to store unstructured data. So if you are in that scenario, so that's where it makes more sense. So again, I think this is not for all solutions out there. Wherever makes sense, you can still use a regular JMS store, and that should do the trick. But if you're looking for that next level of performance, which is definitely the case for me, we have a lot of systems that we actually sometimes we have to dynamically provision several production servers to keep up with the load. So this was like pre-cloud computing days. We had to manually install, manually create new servers on the fly. So now with the cloud computing, there is more flexibility on that. And that's the cool thing about a lot of these trends: cloud computing, NoSQL, messaging, social, mobile. They're all basically, again, to me, they're all patterns. Okay, they're all fit together. It's not like one of them is going to replace the other. They all have their niche space. They all solve a particular problem. So they're all just part of the catalog of patterns for me. So.
This data store will come in the Oracle the messages from
Can you ask me again?
Like the message store, because already your messages are stored in the queue.
Right.
Like for a given time.
Right.
Program, whichever program. The store you are storing like only to store the data, like for the future reference or whatever.
Right.
Other than that, it means what I mean to say, ask you is like it is after picking the message from the broker, you are going to store the persisting.
Right. What happens like in Spring, if you are using a typical JMS without Spring integration, that is the case. But in Spring integration, for performance reasons, whatever, a lot of these queues are in memory only. So when you put some message into a queue channel, Spring integration queue, it's not the same as the JMS queue. So it's basically transient queue store. So you can make it a JMS queue if you want. There's a flexibility. So a lot of these are just in memory. So that's why you want to use these message stores. So, but you can always make all these queues JMS queues if you want. But that comes has the overhead, right? So.
Channel is actually a Spring integration. Queue channel is actually
right.
to process your message.
Right.
Message is picked from your broker. For example, we are using a RabbitMQ broker. So you post the message to the broker and from the queue.
Right.
Queue. And from the queue, your Spring integration, what it does is it will listen for the message and pick it and process it.
Yes.
What is the point of storing persisting again this message, same message again?
Right. Right. Yeah, in that case, you are right. If you already have active RabbitMQ as a store, you can keep going back to that. Or if the use case is to split the message into a smaller message, work on that, get the real one. So if you want to use the RabbitMQ, you may have to write extra code. But with the claim check-in, it's already there, right? So you store, you get an ID, and then you go get it back. So that's sounds cool. Thank you all. So hopefully it's your time. It's 2 minutes after, so.